Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 9 of a unit electrostatic potential and capacitance. So let's begin with today's class. In today's class we are going to discuss about the electrostatics of a conductor. Actually this is the part 2 of an electrostatic of a conductor. If you remember the previous class we were discussing about the how the conductor should behave when it is placed in external electric field, and in that series we are just moving on. So let's begin with today's class. Yes, first is the polarizability. Now what is it? What we can say about the polarizability is it is the ratio of induced electric dipole moment P to the applied electric field. It's an P induced divided by electric field. It is the polarizability. Now, what is polarization of a dielectric substance? When we can say polarization of a dielectric substance, it is the process of inducing equal and opposite charges on the two opposite faces of a dielectric on application of electric field. I hope you remember this. Let's say this is the one of the plate having a positive charge. This is one of the negative plate. So this forms the external electric field, and this external electric field is in positive x direction. Now suppose I have placed a one dielectric slab at this place. So what happens? What was the situation? The negative charges would be available at here, and the positive charges would be at here. But mind well, this is dielectric. This is not a conductor. So I cannot say that E inside would be a 0, but this E inside would be not equals to 0. What is it and how is it? We are going to just see it in next slide. But before we move to the next slide, please let me know that is it clear up till now that if it is the case of a conductor, if this is the case of a conductor, then E inside will be definitely a 0, because this E external and E induced would be equal, and E net within the metallic slab or within the conductor would be a 0. But this is dielectric, so this is not going to be 0. What is it? Let's have a look. So what we know is that applied electric field is E naught, and electric field due to polarization it is an EP. So let's have a value of E naught and EP. I can say E naught is equals to sigma by epsilon naught, and EP, it's an electric field due to polarization, it's in sigma p minus divided by E naught. So both are having a different direction. You know this. This was the plus, this was the minus. This is the direction of E naught, which we call as an E external, and this is the dielectric slab. And induced dipole moment would be in this direction. So these two are having a different direction, as they are having a different direction, I need to subtract for the electric field because it is a vector quantity. So this is E is equals to sigma by epsilon naught minus sigma p of epsilon naught, and the net electric field will be something like this. Yes, it is. If you see this very carefully, then it is a certain reduction into the net external electric field. It is somehow something less than this. Yes, is it clear? Is it? Yes. So let's move on to the new concept. It's a concept of dielectric constant. Very, very important concept. Look at this very, very carefully. So what is it? What I know about the dielectric constant is it is the ratio of applied electric field. It is the ratio of the applied electric field intensity to the net electric field intensity on placing a dielectric between two opposite charge plate. This is called as a dielectric constant. It's a ratio of applied electric field to the electric field intensity on placing a dielectric between two plates. Yes, so it's a ratio of the E naught is to E. Now what is E naught? It is an external electric field. It is an external electric field. What was that? External electric field. I know that E naught is equals to sigma by epsilon naught. This is external electric field. And what is the electric field? When dielectric slab has been placed between the two oppositely charged plates. It's an it's in sigma minus sigma p divided by epsilon naught. That we have gone through this in previous slides only. So if I take a ratio of this, if I take a ratio of this, it would be a sigma by sigma minus sigma p. Okay, now tell me, E naught, this is the external electric field and this is the electric field. When dielectric slab has been put between two plates, that E naught would be always greater than E. E naught would be always greater than E. So always remember the value of a dielectric constant. Value of a dielectric constant is always greater than 1. It could not be. It could not be a less than 1 anywhere. Anywhere it could not be a less than 1. It is always a greater than 1 number. So let's find out the relation. Let's find out the relation between surface charge density sigma and induced surface charge density sigma p. So we are just requiring this, that this is the positive charge plates, this is the negative charge plate, this is the dielectric slab. Here this would be the positive, this would be the negative. Yes, so I just required to find out the relation between surface charge density and induced surface charge density. We know that electric field intensity, it is equals to E is equals to E naught minus EP. We also know that E naught is equals to sigma by epsilon naught. Now let's put up the value within the relations. Then what I can have is, this is E is equals to E naught minus EP. I know that this net electric field after subtracting by polarizing electric field, it is a sigma by epsilon naught into k. Here k is the dielectric constant. I hope you remember. This k is the dielectric constant. This is dielectric constant is equals to E naught, we know sigma by epsilon naught, EP I know sigma p by epsilon naught. So if I replace the value, this sigma by k is equals to 1 by epsilon naught into sigma minus sigma, and E naught, it's an epsilon naught would be a constant. So if that has been cancelled, sigma k is equals to sigma minus sigma of p. So sigma p I can write like as a sigma minus sigma by k. So this is sigma of polarizing or sigma of an induced is equals to sigma into bracket 1 minus 1 by k. Yes. Now one thing very important. What is sigma? What was it? Have you remembered the first unit? We have defined three different charge densities. We have defined the three different charge densities. Shall I write this? Shall I? Yes. One of them was the lambda. It's in Q by L. It's a linear charge density. This is linear charge density. Another is the sigma. It's a Q by A. It's a surface charge density. And one more. It's a rho. Would be equals to Q by V. It's a volume charge density. So the three were the lambda, sigma, and rho. So from this relation, I have one more relation. This Q induced divided by area is equals to Q total divided by area into bracket 1 minus 1 by K. So if this area would be in constant, it's in Q induced would be equals to Q total into bracket 1 minus 1 by K, and this is just the magnitude. This is just the magnitude. If I write this with sign, then this should be of negative nature. This should be of negative of nature. I hope these things are clear to you. Please remember this. Please rem please remember this. We are going to use this relations. We are going to use this relations when we are going to discuss about the capacitors and dielectric in the capacitors. So this is very important. So let's have a look that what we have achieved. It's in Q induced that should be is equals to minus of Q of total into bracket 1 minus 1 by K. Yes, so this is what we have achieved. It's in Q induced is equals to minus of Q of total into bracket 1 minus 1 by K. This K, this K is the dielectric constant of material. For metal, K is equals to infinite. For metal, this would be an infinite. So if you look at this, that suppose this is positively charged, this is negatively charged. If if I have been put, if I have been put in first case, let's say this is metallic slab. It's a metal. So if any metallic plate has been placed within an external electric field, the things would be that here in this situation negative charges would be there, here positive charges would be there. So what should be the value of Q induced? Let's have a check. It's in Q induced that should be is equals to minus of Q total into bracket 1 minus 1 by K, and for metal it's an infinite. So this is equals to minus of Q total 1 minus 1 by infinite, it's a 0. So this is equals to minus of Q total. So that means the induced charge would be equals to the total amount of charges that is available on the external electric field. And if these two are equal, that means this is the direction of external electric field, this is the external, this is the direction of induced electric field. I hope these things are clear. Yes, and within the metallic surface here, that's an E inside would be equals to 0, that we know. So this is how it has been derived, that within the metallic surface, the induced and external electric field are the same, and so that net electric field will be always equals to 0. I hope this is clear. Is it? Okay. And now let's say we have placed dielectric slab. We have placed dielectric slab between external electric field, then the situation would be that, let's say this is the external electric field, this is positive, this is negative. and this is the dielectric slab. For now, assume that its k would be equals to 2. So, if its k would be equals to 2, let's find out the value of q induced. This q induced would be is equals to minus of q into bracket 1 minus 1 by k. So this would be equals to minus of q into bracket 1 minus 1 by 2, and this would be minus of q into bracket 1 minus half, it's in half, so this is equals to half of the total charge. So this is half of the total charge. So let's say if here, let's say suppose 6 charges would be there. If here on an external electric field there are 6 charges are there, then on this side, only 3 charges would be there. On this side only 3 positive charges would be there. So now I hope you understand this, that if this is the value of E external field, this should be the direction of E induced, but E external could not be equals to E induced. So whatever I get in the field, in the plate, it's an E induced minus of, sorry, what I need to write is it's an E inside would be equals to this E external minus of E induced. I hope these things are clear. Yes, and that would be E naught by K. Now you remember this. Yes, everything is clear about the dielectrics. Is it clear? Any doubts? Any concern? I hope these things are clear. So let's move to the next concept very quickly. And this is very, very important concept. This is the concept of grounding. Yes. Now, let's say this is the sphere, and this sphere is given a charge q, and it is having a radius r. Yes. So what what they can ask is that, let's suppose if I have connected with the ground. Yes, this is the symbol of grounding of a conductor. Yes. So now what would be the situation happen? First thing, what does it mean when you connect with the ground? That when you connect with the ground, when you connect with the ground, total potential on the surface of a conductor is zero. Yes, this is the first and foremost understanding, that when you connect any sphere with the ground, your potential on the surface of a conductor would be always a zero. Yes, I hope you remember. Yes, next, what about the charges? Sometimes do we understand that when we connect with the ground, our total charge would be a lapse, or the total charge would be a zero? This is could not be the case every time. That charge may transfer from sphere to earth, or maybe from earth to sphere. So we are not sure about this, that what happens with the charge. There are situations that charge will be transferred from surface to a ground, surface to earth, and there may be possibilities that charges has been transferred on a reverse node, so from the earth to the sphere. So we cannot say anything uh, confirmly about the charges when our spheres are connected with the ground. But when and when we say that my sphere is connected with the ground, I am pretty sure, I am pretty sure that my potential on that surface would be zero for sure, 100%. This is sure shot. I hope these things are clear to you. Is it? So let's have a look at the applications of this. Let's say that suppose this is one sphere and this would be the other. This sphere has been grounded. This is given a charge q1. This is the radius r, or let's say this is r1, and this outer radius, this radius of outer sphere is r2. Now what I have been asked is that find out charge on the outer sphere. This is what they require. Find out the charge on the outer sphere. So what I can do is, let's assume that the outer surface must be having a charge x. So let's write down the potential at this surface. Mark this point as an A. So what I need to write down? I need to write down the potential at A. So what it would be? What would be the potential at A? So if I write this, what I can have is here it's in K Q1 divide by, it's in for Q1, this is the outside the point, and when point is outside, you need to write down the distance. I hope you remember this. It's in K Q1 divided by R2 plus K into for x it is the point on the surface, so it's a K into x by R2. Now as I know that point A has been grounded, as it is ungrounded, VA should be equals to 0. Yes, because this surface is connected with earth. This surface is connected with earth. Yes, so if I solve this, it's in K Q1 by R2 should be is equals to minus of K into x divided by R2. This would be gone, this K would be gone, and this x should be equals to minus of Q1. I hope these things are clear. Is it? Is it? Is it? Is it always clear? Yes? Like to do one more? Are you? Let's have a look. What next? Let's have reverse of the situation. That this is this is the Q1, this is the R1, this is the R2, and let's say this has been grounded, the inner sphere. This is the X. The question they have asked is that find out charge Q, that means charge X, that find out charge x, and you can see that sphere has been grounded. So you need to find out the charge x. How can you do this? So our first priority is whichever the sphere which has been grounded, make their potential and then declare that they have been connected with the ground, so their potential would be a zero. Yes. So what I can write is, I know that potential at A should be equals to 0, but what its value would be? Yes. So this is K multiplied by X divided by R2 plus plus it's in K Q1 divided by minus it's in Q1. So for Q1, point A is inside the body, and when you are having a point inside the body, to write down the potential you are going to use the complete surface. Yes, that means your complete radius, and your radius is R1. It's in KQ1 by R1, and that should be equals to 0. So if I solve this, it's in K into X divided by R2 should be is equals to minus of K multiplied by Q1 divided by R1. This KK would be a gone. This KK would be a gone. And so that X should be is equals to minus of Q1 multiplied by R2 by R1. I hope you have been landed on the same answer. Is it? Is it? Do you have a same answer? Are you sure? Yes. Are you? Great. So shall we move to the next category of question? Shall we? Okay, let's move on. Let's move on. Suppose they have given that this is one of the sphere and this is another sphere. What they have given is that here they have given plus q charge, and let's mark this as a first and mark this as a second. What they are going to ask is that find out induced charges on the inner and outer surface of of sphere 2. Find out the induced charges on the inner and outer sphere surface of the sphere 2. So let's look at this very carefully. This is very interesting. This is plus q that has been given. So this plus q charges would be available on the surface of the sphere. First surface, what I mean, see, it's a plus q. So so what I know is that q induced is equals to minus of q into bracket 1 minus 1 by k. Here we are talking about the metallic spheres because no dielectric has been seen, and when there is no dielectrics has been seen, this k would be an infinite. So this q induced would be equals to minus of q. I hope these things are clear. So if this is plus q, the induced charge on this surface, I mean in inner surface of second sphere, would be a negative one. Look like this. Yes. And outer surface of the second sphere would be a positive one, because again it is q induced is equals to minus of q, something like this. Yes. And even this is must be a value of q. Even this must be a value of q, but negative. It's a minus of q. I hope those things are clear to you. Is it? So, what I can write is for sphere 2, q inside would be equals to minus of q, and q outside would be equals to plus q. This would be the final and correct answer. Yes? Did you understand the same? Do you? Are you sure? Are you sure? So, would you like to do one more of same category? Let's have a look. Look at this. At this place, a q is given. At this place, 2q is given. At this place, 3q is given. This is, let's say, R1. This would be R2. And this would be the R3. Yes? Now, what they want is find out total charges on the inner and outer surfaces for sphere 2 and 3. This is what they require. Now, this is first, this is second, and this is third. So they want that you need to find out the total charges on the inner and outer surface of the sphere second and sphere 3. So how can you do this? How can you do this? So let's induce the charges. This is plus q. So on this side a negative of charges would be there, and the negative charge would be of same value. It's in minus of q. So if minus q is there here, plus q will be induced. I hope those things are clear to you. Is it? That this is the charge of plus q. So because of this plus q, the total charge, the total charge on this surface, it's in q plus 2q. That means it is a 3q. So now on this surface, I am talking about the inside the surface. I am talking about the inside the surface of third sphere. The induced charge would be of negative in nature. That is correct. But it is of which value? What would be the value of it? Yes, the total charge is 3q. That means total charge of minus of 3q will be induced over here. And on the outside, a positive charge will be induced there. I hope these things are clear to you. And that positive charge will be of 3q. So this total charge on the outer surface, this total charge on the outer surface will be of 6q. Is it clear? Is it? So if I need to write down the answer, what I can write is for sphere 2 and for sphere 3, this is inside and this is outside. So for sphere 2 inside it would be a minus of q, and outside it is plus 3q. For sphere 3 inside it is minus of 3q, and outside it is plus 6q. So this would be your answer. I hope these things are clear to you. Is it? Is it? Yes. So will you be able to solve this kind of question? Are you sure? Are you sure? Will you be able to solve this kind of question? Can it be done? Can it? Okay, great. So shall we move to the next level? Shall we move? Okay, let's have a look. What they ask is that, let's say that this is one plate and this would be the other plate. Let's say this is charge Q1, this is charge Q2. What they ask is that find out charge on each surface of a plate. This is what their requirement is. You need to find out the charge on each surface of a plate. So for this we have a very good trick, but to follow this trick you must remember that on this side the charge would be always q1 plus q2 by 2. On this side the charge would be always a q1 plus q2 by 2. So the charge on this side, let's write it down at this point of time, it's an x. So charge on this side would be the remaining amount from the q1. Now what is it? So what I can write is x is equals to q1 minus of q1 plus q2 divide by 2. So this would be equals to 2q1 minus of q1 minus of q2 divide by 2, and this 2q1 minus q1, it's in q1 minus of q2 divide by 2. I hope these things are clear to you. Is it? Is it? So this value of x, this value of x will be, this is equals to q1 minus of q2 divide by 2. Yes. Now on this side the charge available will be an inducing charge, it's an induced charge of this, so it is just the minus of this. So what I can write is it's an minus of xq, and if it is minus of x, it's an q2 minus of q1 divided by 2. So on this side what it would be, on this side what it would be, yes, it's an, let's say, q2 minus of q1 divided by 2. So if I write this, it's in 2q2 minus of q2 minus minus plus q1 divide by 2, and that would be equals to q1 plus q2 by 2. Yes, this is always the case that charge on this side and charge on this side would be always equal. I hope you remember this. Yes. So can you do this? Can you do this? Let's have a look then. Let's have a look. That this is first plate. This is the second. This would be 2 microcoulomb. This would be 4 microcoulomb. What they ask is that find out charge on each surface of plate. It is the requirement. So what I can do is it's in here, it's a 2 plus 4 divided by 2. Yes, this is 2, this is 4. So this is 2 plus 4, 6, 6 by 2. This is equals to 3 microcoulomb. Yes. Now, what I understood this, that this is 2 microcoulomb. If I have been given on this side 3 microcoulomb, so what I need to write here so that this and this becomes 2 microcoulomb. What is it? Yes, it is minus of 1 microcoulomb. Now again recheck. This is plus 3. This is minus 1. So the remaining would be a 2 microcoulomb. Now I have did it correctly. Now what happened next? What happened next? This is minus 1 microcoulomb. So charge would be induced. It is of same magnitude but opposite nature. So this is plus 1 microcoulomb. Now again I need to check this. that I have given 1 over here. Total should be a 4. So the remaining part would be on this section. So this is plus 3 microcoulomb. And yes, this things have been done. Is it over? Yes. You guys have a fun in this. Do you? So, ready to move? One more question. Yes. Let's have a check. Now it is having that this first plate, this is the second plate, and this is the third plate. Yes, this is 2 microcoulomb, this is 4 microcoulomb, this is 6 microcoulomb. What they want? They want that find out charge on each surface of plate. This is what the requirement is. Find out the charge on each surface of the plate. So what you are going to do? Yes, do it quickly. Make it fast. It's a 2, 4 and 6. So this should be equals to 2 plus 4 plus 6 divided by 2. This is 6 plus 6, 12, 12 by 2. That's in 6 microcoulomb. I hope these things are clear to you. If this is 6, the total should be a 2. So what I need to write down, it's in minus of 4 microcoulomb. I hope this is clear. Yes, because 6 minus 4 would be a 2. Now this is, if this is minus 4 microcoulomb, if this is minus of 4 microcoulomb, I need to induce the charge, and this induced charge would be a minus of, it's a plus 4 microcoulomb. So because this is minus, this is 4. Now total charge on this plate, total charge on this plate should be a 4. Already you have given the plus 4 here, so this would be a 0 microcoulomb. And if it is a 0 microcoulomb, it is a 0 microcoulomb. No need to write minus of 0. I hope you understand this. Yes. So if this is a 0, the total charge should be given on this plate should be a 6 microcoulomb. So it would be a plus 6 microcoulomb. Now again look that charge on this side and charge on this side are equal. I hope these things are clear to you. Yes. Yes. Did it? Did it? So I hope you can do a questions like this. I hope this is feasible. Yes, is it? So shall we move to the next level? Shall we? Okay. So let's say suppose this is one of the sphere having radius r, and it has been given a charge of, let's say, 4 coulomb. Another sphere is there having same dimension. This two spheres having same dimensions, and this has been given 6 coulomb of charge, and let's say they came to a contact, and again they are separated like this. So let's say this is q1, this is q2, now this is q1 dash probably, this is q2 dash probably. Yes, what you need to find out, that find out value of q1 dash and q2 dash. This is the requirement, this is the requirement. It's an, you need to find out the value of q1 dash and q2 dash, how it can be done. So first thing what you understand is that this two people are having a same dimensions, these two people are having a same dimensions, and when this are having a same dimensions, I have written this on the first unit, electric charge and field. When two spheres or when two objects having the same dimensions, when they brought into a contact, they are going to share the charges, and after sharing of the charges, the new charges will be equals to q1 dash, or I can say it's in q2 dash, that would be equals to q1 plus q2 divided by 2. So that should be is equals to 4 plus 6 divided by 2, and this would be equals to a 5 coulomb. So charge with q2 dash should be a 5 coulomb, and charge with q1 dash should be a 5 coulomb. Look at here, the total charge of the system has been conserved. I am talking about the system, and here q1 and q2 altogether makes my system. So this total charge would be equals to 4 plus 6, it's a 10. Again q1 dash and q2 dash, it would be a 10 coulomb. I hope these things are clear. But this is the case when this two must be having the same dimensions. If if there are the cases that these two spheres are having a different dimensions, if these two spheres having a different dimensions, what would be the case? What happens next? So let's have a look. This is a concept of sharing of charges. This is the concept to share the charge. So what we have done is that two conducting hollow spherical shells are there. Both the radius would be r1 and r2. That means these two are having a different dimensions. They have been provided with the charges q1 and q2, and they are at large distance, are joined by a conducting wire. So what I need to find out, I need to find out the final charges on sphere q1 and q2 respectively. So one very important thing is, when you connect two wires, they are going to share their charges, but up to what time or up to what situation this charges or the flow of charges will be continued. So what I can know is, what I understand is that these two spheres will share their charges until they reach to common potential or a same potential. So they are going to transfer the charges, or they are going to share the charges until they are having a same potential. So transformation of the charges would be continued, and they are going let's say this sphere will give them a charge, or charge would be flown from q2 to q1, but this will happen until they are having a common potential. So if I write the potential of first, it would be a kq1 by r1. If I write down the potential of second, it's an kq2 by r2. So if I can compare this because both are having the same potential. So what I can have is, it's in q1 by q2 is equals to r1 by r2. Now I know that my charge is always conserved for any system. Conservation of charge would be there. So what I can have is, it's in q1 plus q2 is equals to q1 plus q2. This is the charges after they have been connected, and this is the charge before they have been connected. So if I solve this 1 and 2, what I can have is that q1 is equals to q1 plus q2. It's a total q multiplied by r1 divided by r1 plus r2, and this q2 is equals to q total multiplied by r2 divided by r1 plus r2. I hope these things are clear to you. Even you must remember this formula. This will help us. You must remember this formula. This will help us to calculate the numericals in a quick manner. I hope these things are clear to you. Is it? Is it? Any doubts? Have you written this formula? Have you written this formula? Yes? Yes. So let's calculate the numericals. Suppose the sphere is there, having radius of 4 meter, and this charge is having a 4 microcoulomb. this is another sphere having a charge of 2 microcoulomb and its radius would be equals to 6 meter. What they ask is that find out charges on both the spheres when when they are connected with conducting wire. So what you need to write is that q1 dash is q total multiplied by r1 divided by r1 plus r2. So this q total, this is 4, this is 2, it's a 6 microcoulomb multiplied by r1, it's a 4, divide by r1 plus r2, 4 plus 6, it's a 10. So this is 24 by 10, this is 2.4 microcoulomb. I hope this is clear. And this q2 dash, it is equals to a q total multiplied by r2 divided by r1 plus r2. So this is equals to 4 plus 2, again 6 multiplied by 6 divided by 4 plus 6, it's a 10. So 6 into 6, 36 by 10, it's a 3.6 microcoulomb. So this is the value of q1 dash and q2 dash. This is the value of q1 dash and q2 dash. From this, I hope you must calculate that initially this sphere is having a charge of 4 microcoulomb, and now after a connection it is having a charge of 2.4 microcoulomb. So there must be a transfer of charge from this sphere to this sphere, and the what amount of charge has been transferred? It is a 1.6 microcoulomb charge has been transferred from this sphere 1 to this sphere 2. That's why only this is 2 microcoulomb, and after connection it is having a 3.6 microcoulomb. So it has received a 1.6 microcoulomb of charge, while first sphere have donated 1.6 microcoulomb of charge. I hope these things are clear to you. Is it? Is it? Now, all last question of today's class. Last question. But do it very carefully. That this is q1 is equals to 4 microcoulomb, and this is of 4 meter. Another sphere q2 of 6 microcoulomb, and it is having a radius of 6 meter. If these two spheres are connected with conducting wire, then find out their charges after connection. So what would be the situation? What I know is that q1 dash should be is equals to q1 dash should be is equals to q total. It's a 4 plus 6, it's a 10 multiplied by 4 divide by 4 plus 6, it's a 10. So this would be a 4 microcoulomb, and from the formula you know this that q2 dash would be equals to a q total, it's a 4 plus 6, it's a again 10 multiplied by r2, it's a 6 divide by 4 plus 6, 10. So again this is 6 microcoulomb. Now why this happens? Why this happens? Look at this. Even though they have been connected with the conducting wire, their charges remains the same. Their charges remains the same. Why this happens? Okay. Let's do one thing, that find out their potential. V1 is equals to K multiplied by 4 microcoulomb divide by this. It's in K. Yes, you, if you wish, you can write this K 10 to the power minus 6. Write down the value of this potential. It's in K multiplied by 6 into 10 to the power minus 6 divided by 6. So again, this is K into 10 to the power minus 6. So this two are having already at the same potential. So even if I am going to connect this two, even if I am going to connect this two, as their potentials are equal, they are not going to share the charges. Yes, I hope those things are clear to you. The two spheres, when connected by a conducting wire, will share the charge so that their potentials can be equal. But if their potentials are already equal, then there would be a no charges would be going to be shared. I hope these things are clear to you. Is it? So any doubts on this? No? So let's wind it up here. Thank you. Goodbye. Take care.